Hello and welcome back to another video. In this problem, we're asked to solve each equation for x. We're going to do this by using the relationship between exponentials and logarithms, where if we have b to the x equals y, then log base b of y equals x, right? These two are equivalent, and we're going to be switching between them to solve these equations. So first we have a, 2 to the x minus 5 equals 3. Therefore, log base 2, right, the base of the exponential and the log are the same, of the other side, which is 3, is equal to the exponent, which is x minus 5. So base to the exponent equals something becomes log base of that something equals the exponent. Adding 5 to both sides, x equals log base 2 3 plus 5. And if you're uncomfortable with using log base 2, you can use change of base to say this is ln of 3 over ln of 2 plus 5 equals x. This is already the solution, so it's not entirely necessary, but you're not always going to be able to do log base 2 if you're actually trying to find the solution in a decimal form. In b, we have ln of x plus ln of x minus 1 equals 1. And solving this is going to be a little unorthodox, but we're going to be able to do it. First, we're going to subtract ln of x minus 1 from both sides. These cancel, and we're left with ln of x equals 1 minus ln of x minus 1. ln is log base e, if I can write that in there. Therefore, using this relationship, we can say e to the power of the other side, 1 minus ln of x minus 1, equals the thing that the log is taking on, x. This is therefore e to the 1 minus ln of x minus 1. We can use the properties of exponents to say if we have subtraction within a singular exponent, we can take it out and say e to the 1 over the thing that 1 is subtracting, e to the ln of x minus 1. This is equal to x. And I'm just going to simplify this a little bit. E to the 1 is just e. And then ln is log base e of x minus 1. So we're going to use this going forward. To go here, x equals e over e to the log base e of something equals that something, right? If you have a log in the exponent, all of this basically just cancels. Again, it has to be e to the log base e, or 2 to the log base 2. Whatever it is, it's just equal to what's inside the log, x minus 1. Multiplying both sides by x minus 1, we get x times x minus 1 equals e, because here it just cancels, and on this side we multiply by x minus 1. Doing this, we have x times x is x squared, minus x, going to subtract e from both sides, so this is equals 0, subtracting e, over here, minus e, and now we have a quadratic. So we can use the quadratic formula to get an actual solution. So x equals negative b, so negative 1 is positive 1, plus or minus the square root of b squared, b is negative 1 here, so negative 1 squared is 1, minus 4, a is just 1, c is negative e, over 2a is just 2 times 1, which is 2. Doing a little bit of simplification, we have 1 plus or minus the square root of 1, negative 4 times negative e, well, negative 4 times 1 is just negative 4. Negative 4 times negative e is plus 4e over 2. And so the solutions to these equations, a, the solution is ln of 3 over ln of 2 plus 5, and the solution for b, x equals 1 plus or minus the square root of 1 plus 4e over 2.